Good. Welcome, everyone. I know it's getting a little late on first day here, so I'll try to keep you guys awake and entertained. My name is Grant McAllister. I'm a senior principal engineer with Amazon Web Services. I'm an actual engineer, not a marketing guy. I actually try to make stuff for you guys. I work in the database services group. I spend a lot of time with RDS, and so I'm going to be talking about migrating databases to AWS today. Mostly we'll be focused on RDS and sort of EC2 a little bit, but in general, I think some of it's generally applicable. And I'm very happy to have one of our customers here, Rodney Grilly, who's going to talk about his experiences with AWS and RDS after I go through some of my first stuff. So let's jump right in. So when you think about moving a database to AWS, three of the big sort of possibilities really are Amazon EC2, our compute platform, and that really allows you to do whatever you want because you can choose your own OS, you can choose your own database, whether it's SQL or NoSQL, whatever you want, and really customize it to your heart's content. And a lot of folks do that. My group, we support two products, Amazon RDS, and really that one's about sort of the same sort of things that you know and love with relational databases, but we do a lot of management for you. And a lot of the talk will sort of focus on these two and a lot on RDS and about how to do that. The third one that I don't know how many people are familiar with, but Amazon DynamoDB is a fairly recent addition to the family. It's a NoSQL data store. So if you don't need all the capabilities of a relational database, this is a great data store for you. It's very fast, super scalable. You could dial up and down how much provisioning you want on it. Really very good. I think it's got a record for the fastest growing service in AWS. I think Andy mentioned it this morning in the keynote. So that's another option. I won't talk too much about that because it's kind of a little different, and there's a lot of other talks on Dynamo. So if you're interested in that, I suggest you go to one of those or stop by our database booth in the exhibition hall. So one of the things I tell people is, you can move your standard database over to AWS and run it in the same old way you always have. But I really encourage people to think about the advantages and capabilities of AWS and really embrace those because I think it really helps you with running your database in AWS. And when I mean that, well, first of all, you can build an application. It takes a couple minutes. You can build a database on EC2, or you can build, why is this not working? Oh, there you go. You can build a database in RDS, and it's very quick to get all three of those set up. And then if you want a whole bunch more, it's only a few more minutes to get all that done. And it doesn't have to be balanced like this. You can have just a bunch of EC2 applications. So really, it allows you a lot of flexibility. You can make them smaller, right? You can turn them off in the middle of the day, and you can bring them back in your peak, right? So really, this flexibility about on demand, really embracing that, really can help you with bringing your database there. So I won't go into the capabilities of RDS too much, but I did want to give sort of a basic introduction. Some of the things that we do for our customers and for you is rapid database instance creation through an API, through a console. With 5 to 10 minutes, you get a database all built, all ready to go. It's got backups turned on, as I said. You can do restores. You can make copies of your database really easily. We do scaling. So we do online scaling of storage. We do a small couple-minute outage to scale the instance if you want to go from a small to a large to an extra large to a 4XL. We provide high availability and durability with a multi-AZ offering that allows you to really get a best of practice sort of setup by just checking a box that says, I want multi-AZ when you buy an instance. We allow you to choose when and how to patch your database, but we do it for you, so no more figuring out how to get the binaries on the box, get upgraded, we'll do all that for you. We provide monitoring and metrics. So what do I mean by this? Well, you get CloudWatch Metrics, much like you would with EC2. So you get all things like CPU and a bunch of other utilizations, and I'll show you those. And of course, you get monitoring. If your instance goes down, we restart it. If the box fails, we replace it. We do all those things for you. You don't have to write all that code yourself. And of course, security. By default, security is our first and most important job across all of AWS and of course in RDS. So one of the things that we want to do is make sure you have the capabilities to manage the security in your database, and I'll cover a little bit of that as well in the future here. So one of the things that people told us as well, of course, is that if you're doing a relational database, if you're moving to the cloud, well, typically you have one today. You're using an engine, whether it's Oracle, MySQL, or SQL Server. We can support you today. If you're using a different engine, well, maybe in the future, but this is what we have currently. And it's the same way you use it today. You get a port you get a IP address or a CNAME, and you connect to it with all your same tools, and it works exactly the same way as your database. So there's no real big difference when it comes to using these. It's not a big change. So let's go through some of the things you'll want to think about when you're thinking about migrating. Well, sizing your deployment, picking how large of a database. Now, this is whether you're on EC2 or RDS. It's very similar. One of the things you'll want to look at is your CPU requirements. Now, you might be on a physical piece of hardware in your shop. So trying to compare that to the EC2, I know there's a lot of different instance classes. It can be a little confusing. What I really tell people is go look at the number of physical cores on your server. Go compare that to the number of virtual cores and try to pick something that's fairly close. That's about the best approximate fit you can get to start with. From a memory perspective, obviously you can just choose the same sort of memory size as you have today. But I also tell people this is a great time to go look at the memory your database is actually using. How much DB cache do you have set up? How much memory are you using for your processes or your threads? And the other way to look at it is just to see how much free RAM you have on your current box. Because I know people that they'll have like a 60 gig box and they'll still have like 30 gig of free RAM. Now, the complex thing with either Linux or Windows is to find out how much free RAM you actually have. Modern operating systems actually tend to cache all your disk activity. So they'll use all your free RAM. You'll end up with like 50 meg free. And so you're like, wait, I didn't have any free RAM. But you might have 5 gig in a page cache in Linux. Well, that's essentially freeable on a database box for the most case. So in that case, you may actually be able to go with less RAM than you're currently using. For storage, this is a pretty easy thing. You can look at how much storage you're currently using, how big your database is. That plus a little bit of extra space for logs really will carry you through. Now, one of the new offerings we have is called Provision IOPS, or PIOPS for short. And this allows you to order the amount of IOs per second that you need for your machine. So before we had, and you can still get this, we have classic sort of EBS or classic RDS, where you were in a multi-tenancy environment when it came to I/O, and therefore you kind of had to, sometimes you got really good performance, other times you maybe got a little slower performance. Now you can say, I need 3,000 IOPS, I can order that. And the way you want to find that out is just go to your current system and look at how many reads plus writes you have, add those up, add a little buffer, and that's what you can order, and you're going to be pretty well set up. Now, this is all going to give you a pretty good swag of the size of machine and instance you're going to need, but my best advice is go order that thing that the swag tells you of the rough size, and then go test your application if you can, because that's going to give you the most valid feedback of where you are. Once you've tested that, then you can really easily resize, because you can scale storage online. It can take a couple minutes to scale the server. You can scale up your, the amount of PIOPS you had or down. And so that's really an easy way to go. Now, how do you decide what your numbers are? Well, this gets to our CloudWatch Metrics. So we produce a whole bunch of metrics. I don't know, you probably can't see them all. There's a whole bunch, and I'll cover a few in detail. But we try to give you the pieces you'd need to make decisions about how to scale, how big of a machine you're going to need. So for example, here's CPU, and you can see I ran a little test where I ramped up the number of threads, and so my CPU gets up to where it's above 80%. And boy, if this was a production application, you'd probably want to look at going to a bigger class of box, because typically you want to run databases in the 70 to 80% maximum range, because if you just have a little spike, then you're going to have a lot of latency and your application's going to be unhappy. We also have pieces like showing the read IOPS here. And so this is an instance that was a provisioned IOPS, or is a provisioned IOPS instance, that has 3,000 IOPS. And so you can see as I ramp up my workload, I get all the way up to 3,000. I don't go above it, because that's all I've sort of ordered. So if I was at 3,000 and running a test, I'd know, hey, maybe I need to go to a higher number again. And one of the interesting ones that a lot of people miss sort of when they think about databases, they think about the memory for the cache, and that's where a lot of the sizing comes in. But you actually really want to think about how many connections you're going to have to the database, because those are going to spawn either processes or threads depending on your database engine. And this is an example where I start off, I think I'm on an extra large here, or a large, no, it's an extra large, and I have about 1.8 gig of free RAM. But I have no connections. And as I slowly ramp up connections, you can see how it dips down. And when I've got a couple hundred connections, I'm actually down to 1.2 gig, right? So if I just tripled that, I'd be out of RAM. So this is a great way for you, again, to see how much room you have and to run tests and to really, with your own engine and your own application, figure out where you are. And so you get all these metrics for free as part of RDS. Now, the other thing you want to think about when you're coming into AWS and building something is really the security model that you're going to have. Typically, you have an application, a database, and by default, you have the same sort of controls that you have for databases in-house or in some other colo, where you control the database access and privileges. So, Who you give accounts to, whether they have, create any table or just select, that's all up to you. And that's sort of the first ring of defense around your database. The thing you get with RDS and EC2 is you get a concept called security groups. And this really allows you to control who has access to the network coming into your database. So they can't even get to that blue ring because they have to get through the orange ring first, right? So if you keep that tightly locked down, no one's going to be poking and trying to break in because they can't physically get there. My analogy is, if you can't get to the door to pick the lock, it's going to be really hard to break in through the door, right? So, that's a great model there. We also offer this piece called Virtual Private Cloud, or VPC. And this is a newer offering that allows you to have full control over your network. So this includes routing, ACLs, like access control lists. You can see in the top right I have an internet bubble, but you can turn that on or off. You can say, I don't want an internet, I do want an internet. So that's really powerful. And your applications also live in that virtual private cloud, so you can control all the network access. And around all of this, we have a great product called IAM, Identity and Access Management. And this really allows you to control who can make changes to all these other pieces. So if if Bob and Fred are admins for you, maybe one does the networking stuff, and so you can say, hey, Bob, you have an account, and now, or a user, and you can control the security groups and the VPC. Ted only controls all the database stuff. He controls who can create and drop databases. So you can really make sure that from an internal security basis, you also have all your bases covered. So that's one of the ones that's kind of a little different from standard. The other thing you want to do is you want to think about really designing your setup for availability and scale. We have many regions across the world, and hopefully one of them fairly close to where either your customers are or where you're using. And in each of those, we have at least 2 availability zones, and some we have 3 or 4 and 5. In this example, I'm just using 2 as sort of the classic model. And a lot of people will start with building the application and the database just in one availability zone. But the problem is if there's a service disruption in that availability zone, you're going to have an outage. So you really want to have replication across to a second availability zone. And this is what you get with RDS by just clicking an option to say, I want multi-AZ. And you get physical synchronous replication that goes across there. And so that's very powerful, and it's, it's a really good setup. The other thing, oh, sorry?
Sorry, is that true for
Sorry, yeah, it's true for our Oracle and MySQL offering, and currently we don't have a multi-AZ offering for SQL Server. Correct. And then for MySQL, we also offer read replicas, because that's a very common model for MySQL. And so you can have those in multiple availability zones for both availability for read scaling. So it's a really great option as far as a setup. So you really want to think about how to utilize these pieces to build a highly available, scalable setup. Now, that setup really does protect you against a lot of things, but if you're on-premise, you know that sometimes you have compliance reasons for backups, but just in general, they're a good idea because they protect against sort of logical things like someone dropping tables or deleting 1 million rows or just having a bad application piece of code run against your database. With RDS, we do automated nightly backups, and we back up your logs that come off your database every 5 minutes. So you can essentially set a retention window up to 35 days, and you can restore anywhere within those 35 days, up any minute. So if last Tuesday the person dropped the table at 1 p.m., you can restore up to 12:59 on that Tuesday, and you can be back in business. And the nice thing is that you can do that as another copy so that you can just take the changes and migrate them back in. So there's a lot of flexibility. And I say this because I know a lot of you probably, if you're on premise, you have particular retention requirements, so we try to meet them with this. The other thing I would say is you can choose your backup window, so you can set it at the lowest part of your window. And it's nice because I know when I was doing on-premise, everybody would want to, like at Amazon, backup at the same time because we got this retail website that gets quiet at night, and so we'd be trying to back up every single database. But the great thing is because we have lots of different customers doing lots of different stuff, it really varies. So it doesn't matter if you want to put all your databases at the same time; those backups will happen, no problem. Now, you can turn backups off, and normally I don't recommend this, even for test instances, because it's really inexpensive. And in fact, with RDS, the first, you get free backup storage up to the same storage sizes of your instance. So, usually people can have 1 or 2 days of retention for free. So even on test, I would have it turned on. But when you're going to do a migration and import, that's the time to turn it off, because at that point you're doing a lot of logging, you're doing a lot of extra work, and you really don't want a copy of your database until the very end. So at that point it's best to turn backups off, and we'll talk about turning them back on in the end. Now, we only do 35 days of retention on automated nightly backups, so if you have retention requirements to go further back, you can do database snapshots. So these are point in time, so a specific time, like if you want to run at 1 a.m., you can go take a snapshot at that time, and you can keep that for as long as you want, years in fact. And the nice part is you can now create those from your nightly backup, so you don't have to even do an extra backup. You just have to say, hey, make a copy of that, and it's basically a logical copy, so it doesn't even really do any work. So that's really nice. So there are some real key differences to RDS that I'd like to sort of talk about a little bit. We don't have host access to the database because of the way we do manageability. And there's some parameter and permissions differences that you'll want to explore. And the easiest way to do this is create a test instance in RDS, and you can do a micro for free for up to a year. So go and play with it. And you can look at what the permissions are on the master user, which is equivalent to sort of the root user or the sysdba equivalent. And it'll have a little less privilege, and you can see if you can kind of match up to what you're doing. And also look at the parameters that we have and what the defaults are. Now, in some cases, I would actually say really pay close attention to the parameters, because you may think, I'll just copy the parameters I have in. But in some cases, we've really looked at the best practices of these different database engines, and they're really set to kind of try to match up to that. So don't just sort of override them, really kind of do the comparison and figure out, why do I have that parameter? I know I have databases sometimes that were 10 years old, and we'd look back at init files, and we're like, why is that set? And, oh, it's got some note, Bob did this in, '04, and we're like, Bob hasn't even been here for 5 years. So that's a good time to sort of revisit and say, do I really still need that parameter? So let's talk about the meat of it. How do you migrate? Well, you've got your application, you've got your database. This can be on-premise, colo, could be even on EC2. The first thing you want to do is fire up an RDS instance. And I have it in gray there to mean like, it's not being actively used. And the simple migration, of course, is you shut down your application, you quiesce your database, and you dump and load. Now, that works great, but once you have to fire the database up again, you've been down for a period of time. Now, if you have a small database, or you can tolerate a bit of an outage, this works great. It's very simple, it's very easy to pull off, but it doesn't work for everyone. So let's talk about a little more advanced migration. So again, we have the same application, same database. We're going to fire up the same RDS instance. But instead of shutting down the on-premise one, what we're going to do is take a copy. So this is whatever form you take for copying. You can use a read replica. You can do whatever you want here from your backups just to get a copy of your database up. And then you're going to do a dump from that. Now, you notice I have a little T1 there. So that's just a time T1 we started this operation. But you notice because we left the application in the on-premise database running, we're actually not in sync, right? It's behind. So what are we going to do to catch up? Well, the great thing about databases is that they store logs of the changes, right? Whether it's MySQL or Oracle or SQL Server, you can mine those log records for the SQL statements, and you can apply them. And so that's essentially what you want to do is you apply those delta changes to catch up. Now, I've shown it as you shut down the application and apply all the changes. But in fact, what you can do, let's say you have 10 logs that you've accumulated, and you're sort of on your 11th one being written. Well, what you do is you first mine and apply those 10 logs while that 11th log is being written, and then you shut down your application and take that last log and push it over. And so this works. This is really quite easy with MySQL because the bin log is a very easy process. A little harder with Oracle. You need log miner, and it's sort of equivalent with SQL Server. But it's all possible, and that's sort of what we have today for moving into RDS because it's a logical format. If you're using EC2, you can do more direct copies depending on your operating system and if you're coming from a compatible operating system. But that's a nice way to do it. And I've seen people do this with as few as a couple minutes of downtime to get from on-premise. Now, the one thing I would say about something like the advanced migration, it's a little more complex. You don't want to do this without testing it. And because really only that final step requires your application down, you can run through 99% of this except for that last little step over and over again, and get it absolutely perfect, get the timing down great before you actually attempt this in production. Oh, and sorry, and there's the application running now. And so they're both in, basically we got all the data, the application's running, you're now in AWS. Now, I showed this all with the application moving over to AWS. you could, of course, run your application somewhere else, but database latency is, the latency between your application and your database is kind of crucial. People always ask me, like, should I run my database and application split across on-premise and AWS? And I say, it can work perfectly fine depending on where you are in relation to one of the regions that AWS has. If it's a couple of milliseconds, 5, 10 milliseconds apart, probably fine. If you're running across a 100 millisecond delay, your users are probably not going to be too happy with you because those database accesses are going to be pretty slow. So once you've done all this, you essentially want to go in, you want to turn on backups, you want to turn on multi-AZ. If you're using read replication, you want to create those now and get everything running. And then you want to tighten down your security. So you might have had extra stuff open to do this migration. You really want to think about, make sure everything's locked down at that point. And then remember we showed the CloudWatch monitoring on CPU and all these other things. You can set up alarms on all of those to make sure that maybe you did all your testing and you did as good as you could, but there's always a difference between what test happens and what happens in production. So maybe the CPU's now getting up there. If you've got nice CloudWatch alarms, you'll know well in advance that you've kind of got to do some more scaling on it. And it's nice that you'll get those notifications. One of the other things you'll want to do is once you have your production environment all nicely created, and you see with multi-AZ and read replicas, is you want to create test copies, nice QA. You can downsize it with RDS. And this is one of the great benefits I was saying again about AWS. All my experience, using databases for 20 years, always our test environment was some rinky-dink little thing that was like, never had all the capabilities of prod. I'd try to go test stuff. Like if we had a clustered prod instance, we never had a clustered test instance. And so people would say, hey, when was the last time you tested stuff? And I'm like, well, they won't let me take down prod. And so the only time I got to test was when I got a new machine every 3 or 4 years, right? That's not really a great plan, right? What you want to do is you want to have basically a smaller sized version of your stuff in AWS. And because you can scale everything down, and it's very cost effective, and then you can have QA runs that exercise all of the same things that your prod stuff does. And this really makes sure that you can do failovers, you can use your read replicas, that everything works exactly the same. And one of the other nice ones is that you can make little miniature development environments for each of your developers. And I love doing this. This is what we do in-house. We have micro instances for all of our developers. They can do all the schema changes, like trying them out. They can have their own copies of test data so they can make changes to run exact scenarios. There's no stepping on people. So it really is a rapid development environment for them. And that used to be one of the big complaints about them using relational databases. They hated this like log jam at the development area. The other thing I would point you at is, this is just for reference. On our AWS RDS main page, we actually have these import guides. And these talk about sort of best practices. For example, in MySQL, when you do an import, if you do 20 gigs at a time, for example, you will end up with a 20 gig bin log. And that's actually kind of hard to apply, so it's much better to sort of chop things into pieces and to do those kind of things. That's just one example of the kind of work that we have very experienced database engineers on each of these engines. They write really good guides, and they've really taken the time to sort of do the best practices of those things. So if you're moving one of these engines in, and even if you're not using RDS, they're great guides just in general. So check those out. They're on the AWS RDS main page. And with that, I'm going to turn it over to Rodney, who's going to talk about his experiences. And we'll take some questions at the end if we have time. So just,
this one?
Yeah.
Great. Thanks, Grant. Okay. Hello, everyone. Again, my name is Rodney Grilly, and I'm a solution architect with the College Board. And today I want to tell you about our specific journey, migrating one of our significant applications to a hybrid solution using AWS. First off, here's the takeaways. But before we go into details about these, with a show of hands quickly, how many people are moving a significant portion of your business processes now or planning to in the near future to AWS? Great. So I'm sure you're concerned about real-life stories about what others have learned. That way you can use those while you're planning your journey. That's what I've tried to pack into this session as much as I could. So who are we? At the College Board, our goal is to ensure all students have the ability to prepare for, enroll in, and graduate from college. Now, another show of hands, how many people have either taken or have children have taken an AP course or an SAT exam? Anybody? Great. You know about two of our most important programs. Today I'm going to tell you about another one that we just released, which is our college planning site for students and parents. It's Big Future. The Big Future initiative is focused on delivering a comprehensive online resource for students to be able to aspire, find, connect, and enroll in the right college for them. Now, with any major initiative, there's challenges. For Big Future, one of the main things was this wasn't a new greenfield application, but it was replacing 3+ legacy applications that had been in place for years. With these applications, you had user experiences that you needed to carry over to the new app, as well as you had data. In this case, our biggest data set was roughly 10 million college lists for students that needed to be migrated. And with the legacy apps, you also have current users using the site. In this case, we had roughly 1 million page views a day on the legacy apps that when we did the cutover, they were going to hit our new application. No slow ramp up. It was all or nothing right as we went through the cutover. And for those user experiences, as they migrated over, we implemented it and had to maintain roughly 16,000 redirect rules to ensure those end-user experiences wouldn't get dead-ended during the cutover. And also on a private note, so just 2 weeks before I was put on this project, I completed my application for an executive master's in IT management with UVA, and then all of a sudden, wow, that's going to be 16 months, roughly 30 hours a week study time, and now I'm going to work for the first year of this to deliver Big Future, first time delivering this scale in AWS. So some people say I'm an optimist, so instead of looking at this as a challenge, I looked at this as an opportunity to learn a lot. Just like the College Board looked at this as an opportunity to deliver something very special for students. And I'm happy to say that in March of this year, we successfully launched Big Future. It's a comprehensive resource for students to be able to get the tools they need and all the information to make the best decisions about college. It's got a brand new search implementation. It has tools for parents to understand how much college will cost and what their options are for paying for school, as well as the ability to create a plan so they can track their progress towards their goals. It also has nearly 200 videos from students and teachers and counselors to help students. And something we're really proud of, there's not a single ad anywhere on this site. It's just about providing information to help people. So now let's look at some facts. First off, it required 35 new assets to be either developed or extended for Big Future. And we'll talk more about those in a minute. It accounts for 24% of our overall page views across all of our products and 23% of the unique visitors across them as well. And during our recent peak event, we were processing 450 web service calls a second, with a quarter of those calls going all the way back to our back-end data center for processing. As far as the architecture goes, 2 years prior to launching Big Future, we had started to develop our SOA capability. We use composite applications for the presentation tier. The only thing they can do is talk to back-end web services. So we took those patterns that we had, we applied cloud principles to them, and then created optimized system patterns for AWS specifically. We then build in the degraded modes of operation because we know things fail and you want to plan for them and degrade gracefully, as well as we conducted sourcing analysis across all layers of the architecture to ensure a balanced and optimized solution. So, what did that mean? We had a year to deliver it, roughly, a little bit under a year. And what kind of work did we do? So if you look here, we have 17 technical assets that were developed to file it. Today we're only talking about one of those, RDS. We could have the same conversation about every other item on that list. Also, there was a number of processes that needed to either be developed or extended to support this initiative. Here's the major AWS components we're using today, and there's a larger number of them that we're planning to target in the future. Again, this is about RDS today, so at least you can see that we are leveraging a lot of the value-added resources that AWS provides. From a systems view, RDS and Big Future is made up of 31 components distributed across our primary data center, 3 availability zones in RDS, or in Amazon's US East, and then other third-party sites. The majority of our components are in Amazon AWS US East. If you see the red box in the middle that says CA, that's our composite application for Big Future. It's implemented as a separate autoscale group, and right now Big Future is processing roughly 1 million page views a day, and we have 100,000 unique visitors a day. During that recent peak that I told you about, we processed 1.9 million page views that day, and we had 250,000 unique visitors. On that day, we scaled to 25 small instances in the autoscale group for that composite app. Now, since we're using SOA-based approaches, the blue items right next to the CA, as well as the ones connecting back to our primary data center, are part of our web service management system. In this case, we're using Layer 7 Secure Span Gateway product for this. And the gray boxes across the bottom are our business services or web services. In AWS, again, we're using autoscale groups to deploy them. Each business service is a minimum of 3 instances because of availability. We're across 3 AZs. And typically, we don't have to scale those at all beyond 3 because 3 is sufficient for the capacity we need. And for this specific presentation, we also have 2 business services that you see are connecting to databases. These are multi-AZ instances of RDS, and we have separate database instances for each business service. We don't combine or mix them. So for our RDS use cases, we have 2. The first is our web service management system that I just started to tell you about. We have Route 53 on the front end, then connecting to elastic load balancers to route traffic. We have the gateway products deployed in three different availability zones, all of them tying back to a single multi-AZ RDS database. Now back in our primary data center, we have a separate load balancer. We have 2 VM instances of the Layer 7 product, but we don't have RDS there, so what do? Well, the products come with embedded MySQL databases, but now we have to maintain master-master replication between them and ensure that it's always working. Our second use case is our business service with a back-end relational database. In this case, the left side of the diagram is showing you that same web service management system. We use this to front every single one of our web services and control access to them. In this case, the set of boxes in the middle are our business service that's deployed in AWS. But wait, this is an elastic set of instances for a business service. And then we have gateways. So how do we route traffic when we have ephemeral instances coming up and down? So we worked with Layer 7 to create dynamic load balancing capabilities where their product is calling AWS APIs to look up the current set of IPs, so we're always routing against active, known good instances of our business service. And then on the back end again, we're using a separate RDS multi-AZ database instance for each business service. So I also want to cover 2 other areas. One is performance tuning. From a SOA approach, we always use layered approaches to testing for performance. So that means we test our business services independently of the front-end composite applications. Because why do you have business services? You want them to be reused. So you don't want to use your front-end web apps to test. We use JMeter test scripts. We ensure that our test cases support the total traffic of all the consumers of the service. And then we perform that complete load test every single time we deploy a new version of the service. This way we're certifying the services and ensuring that when we go to the next layer of testing, which is your composite application, You aren't doing root cause analysis, tracing errors somewhere embedded in a business service that you didn't bother to look at and ensure it was reaching your capacity needs. The other takeaway is high availability through multi-AZ. Again, real-world experience, October 22nd, we had an elastic block storage issue in US East. Anybody remember or read about that? Okay, so we have instances of all of our components across 3 AZs. We had instances impacted, but we had instances in 3 AZs, so we were able to sustain traffic the entire time, along with our RDS databases all failing over. And in our case, your mileage might vary, we saw 15-second cutover times between the primary database and then when the second one started taking on traffic. This is significant for us, at least. 15-second cutover is more than we were expecting, and we were very happy with that. So that's real world, it works, and you don't have to maintain that replication yourself. Now, how do we get our data into RDS? Well, first off, you have to configure your RDS, which Grant has gone into details. I'm not going to go into all those. A couple things I will say, though, are for your auto minor version upgrades, we're setting that to no for now, because typically that's really giving them permission to upgrade it if they're taking on maintenance of your instance. But since you really want to track changes to even the minor versions of your engine, we choose to do that as part of our own change control process. Also, your backup periods and your backup retention windows, you typically set that so it's completed, sorry about that, prior to your maintenance windows. That way you're sure that even though you are backing up the logs, you're still getting a good backup right before the maintenance window kicks in. And security groups, Grant's already covered that, so I don't need to go into any more detail there. As far as our database size, our college list database is 28 tables. The largest table has 45 million rows, and the rest of the tables are under 10 million, just to give you a sense for the size of it. So how did we actually move it? Well, we use standard, tried and true ETL processes and an ETL approach for it. Here you can see the overall table and the set of time estimates that it took us to actually execute them. We're actually doing the extract and transform in step 1. But the main thing here is, in our case, even though it took nearly 8 hours, because we were moving from the legacy apps over to the new application, this was sufficient for us, so we stopped. We didn't need to work any harder or try to optimize it more because it met our specific needs. So what's some of the benefits of RDS? For us, the number one benefit is the multi-AZ database feature and the rock-solid replication underneath the covers that's managed for us so we don't need to manage and monitor it ourselves. Second, it's relatively easy to set up. We're using the MySQL engine for RDS exclusively, but also it's less work to maintain. So if you have DBAs and developers, they can now focus their time on other higher value activities other than maintaining the database engine. So what about some of the constraints? So you'll see that I put perceived in here for a reason. The biggest perceived constraint is not having access to log files. And in 2 slides, I'll say why I think it's perceived, but you can choose yourself. Also, the inability to gain super privilege. You can't get access to it if you do need it. Limited set of configuration settings, which could be seen as a plus or minus. And one of the things that we ran into was that the time zone's set to UTC, and you can't change it. So when you have an application and an app tier that's using Eastern time, and then it's trying to use the date time functions in MySQL, you can start to have issues with the information being represented. So we thought this was a problem, we couldn't change it. But then after doing research, this is actually a best practice when you're doing global application deployments and design. You set everything to UTC so you don't run into problems like this. We didn't know that before, now we understand it, and we're changing our practices to kind of model after this. And what's some of our specific benefits? First off, we didn't have to set up and manage and develop this high available RDS asset. Remember those 17 assets, the technical assets I showed you? And we had less than a year to deliver this, and we're going to have 1 million page views the first day, and we have to deal with the legacy flows. This was one less thing that we had to deal with, so we could focus on the number of other things that were important to actually deliver the solution and be successful. And the high availability, we feel, is there's no way we would be able to deliver that type of SLA ourselves. And it just streamlined the overall delivery of both our web service management system and the underlying business services for Big Future. So to show how working with RDS is different, I decided to put together this table. Your common set of activities down the left side for doing database management, how you would do those in MySQL, and then how you would do those in RDS. Now, remember I talked about perceived earlier, 2 slides ago? Well, if you look at identifying slow queries, well, you might perceive that if you don't have access to that log file, you can't understand when you have slow queries. But if you do some research and find that you can set a parameter, and now that information is written to a table instead, is it still a constraint to be able to query a table instead of a log file, or is it actually a benefit? It's really up for you to decide that, but you need to understand that there's alternate ways to do things. And RDS, like all the other Amazon services, is primarily based on a programmatic approach to interacting with and managing the service. So you need to educate those developers and DBAs so they can be the most efficient in managing RDS. For our roadmap, we would like to see, or we would like to achieve ourselves, a fully automated RDS provisioning via continuous delivery pipeline. This is a big goal for us. We're still using the console to manage and configure RDS today, but we want to fully automate that and have that stored in source control to be executed from. We want to strengthen our DB security between our application tier and our database tier. And we want to, a big one, how many people would like to have replication across regions for your RDS databases? Yes? No? Okay, great. They're keeping track of all these. They said they deliver on what we asked for, so we can hope for the best. And then continue to optimize the cost associated with our RDS and all of our Amazon services. So how can they help? They can provide those multi-region replication tools. They can help optimize SSL connections as much as possible that they can help with that. And for X509-based authentication and authorization, so we can improve our security posture, that last mile between our app tier and our database tier. Now, until 2 weeks ago, I had also on this list that we really wanted a medium instance for RDS. Our databases are too big for smalls, but they're way too small for larges. But with 2 weeks ago, when they announced an RDS medium instance and the lower prices, this is going to allow us, starting in December, to actually achieve a 66% reduction in our monthly RDS fees going forward. And RDS is our single largest line item on our overall AWS bill. So that's huge. That's huge for us. So in conclusion, leveraging these value-added services like RDS will allow you to deliver your products quicker, and hopefully it will allow you to pay less money over time for those same services. RDS is managed differently, so educate your developers and DBAs about RDS so they understand how to optimize the management of it. And with any selection process, you must evaluate not just the technology, but the people, process, and technology aspects of each decision you're making to ensure that you make the best decision for your specific company's needs. So, in closing, just wanted to make sure that if you were curious, I didn't drop out of school to do this. I actually completed it, And the last 5 months, I was able to focus on my capstone project, and in August, successfully graduated with my master's. So it's been a pretty good year for me and for the College Board. Thank you very much.